Just looking at simple harmonic motion and the rise and fall of the tide. So the tide at a harbour can be modelled by using simple harmonic motion. At the harbour, high tide is 12 metres and low tide is 2 metres. Okay, so if that's 0 there, low tide's 2 and high tide's 12. It takes 4 hours to go from low to high. So 4 hours to go from low tide up to high tide. So that means starting here and we go up to high tide and then we come back down and we go up and down and up and down. Okay, so that there, from there to there, takes 4 hours. So that means one whole period, like if you went all the way from here down and back to here, that's a period. One whole period would be 8 hours. And then we go to here and that's 12, and here that would be another 4, which would be 16 hours. Okay, so just looking at that then, we have to show that there is a good model. Now, first of all, you can see that halfway here, you can see that it oscillates. If you go 12 plus 2, you get 14. Divided by 2, you get 7. That means the centre that it goes between is 7. The period, which is 2 pi on n, will equal 8. So that means that n, when you simplify that means n will equal, that equals 8. So n will equal 2 pi on 8, which is pi on 4. So just the amplitude, so the amplitude, we can see it goes halfway will be 7. So from 12 minus 7 gives you 5, and 7 minus 2 also gives you 5. So the amplitude is 5. So therefore your best graph would be your negative cos graph with your n, which is pi on 4t, plus 7, and the amplitude is 5. That's why that's 5. So that's why the best graph is 7 minus 5 cos pi on 4t, as shown. So the next part of the question says a ship needs at least 5 metres of water in order to safely enter the harbour. Find the earliest time that the ship could pass through the harbour. So let's just look at that, just for a line. So how many metres does it need to pass through the harbour? So it needs 5. So if that's 2, it's going to be somewhere here. Okay, so it needs 5 metres. So if that's 2, it needs to be 5. So that means in between 5 metres to pass. Yeah. So 2 to 5. So yeah, so it'll be when x equals 5 metres, then it will be able to pass. So if you get that graph, and we make, for this graph, we make 5 equals 7. So 5 equals 7 minus 5 cos, and then you put it in. I'm just going to find a good spot just to grab to. Okay, so when x equals 5, that would be 5 equals 7 minus 5 cos pi on 4t. So that means minus 2 equals minus 5 cos pi on 4t. So that's cos pi on 4t equals minus 2 on minus 5. So cos pi on 4t equals 2/5. So that would mean that pi on 4t equals, so So cos is positive here and here. So the first time when this would happen, we put cos the minus 1 or 2/5, and then you go, we've got to make sure that that is in radians, so I'm going to times it by pi on 180, and then shift cos in degrees, times pi on 180, and then I'm going to times 4 and divide by pi. Low tide is at 1 a.m. You've got 2 hours, 29 minutes. So if you go 1 a.m. plus 2 hours, 29 minutes, that would be 3:29 a.m. Okay. So the latest time it could leave would be right there. So that would be just in the next quadrant. So you can see that it is in the next quadrant, which is 2 pi minus cos the minus 1 of 2 on 5. Okay, and then we're just going to make sure that this part here is in radians. So I'm typing pi on 180. Okay, and that's what we then also have to times by 4 on pi, because that's what pi on 4t equals. And once we get this time, we have to add it on to 1 a.m. So it equals 7 hours and 31 minutes. So if you add that on to 1 a.m., ends up being 8:31 a.m.